So the next example is example 9. 9. And this one, circle that 9. This one, the directions are find a polynomial equation with integral coefficients that has the given numbers as roots. And the given numbers are 1, -3/2, and 2. So I'm going to compare this to factors of just regular numbers, like the factors of 8. If I get the factors of 8, or some factors of 8, say 2 and 4, and I multiply them together, I get 8. So if I get the factors of a polynomial and I multiply them together, I should get the polynomial. It's the same idea. And we're going to be using the factor theorem for this. It says a polynomial p of x has x minus r being a root, as a factor if and only if r is a root. So what they're saying is, if we have a root, we can get this as a factor just by going variable minus that root. So if we have all these factors, we can multiply them together and get a polynomial. If that didn't make sense, it will be clear what I'm talking about when I do this example. So I'm finding a polynomial that has these as roots. So since these are roots, x minus r being 1 here, these roots will have this as a factor. This polynomial will have this as a factor. So, and if I multiply them all together, I'll get the polynomial. So x minus r, and then x minus -3/2, that's r again, and x minus 2. If I multiply these all together, equals 0, I'll get a polynomial equation. Then all I have to do is multiply it by a constant to get integral coefficients. So what I'm going to do here is just multiply. X minus 1 times x plus 3/2 times x minus 2. So I'm going to have x squared plus 3/2x minus x and minus 3/2 times x minus 2, equals 0, And then I can simplify. That would be x squared plus, this becomes, what, 2/2? Negative 2/2. So 3/2x minus 2/2x minus 3/2. Go ahead. No problem, that's fine. And then multiply by x minus 2 equals 0. So if I simplify this, I'll get x squared plus 3 minus 2 is 1/2 x minus 3/2 all times x minus 2 equals 0. So then I just keep going. X to the third minus 2x squared, and then this piece plus 1/2 x squared, and then minus 2 times 1/2 is 1 minus x, and now minus 3/2 x plus 3/2 times 2, or these are negatives, is 3. Had a hard time thinking about that. Equals 0. So what I could do is add like terms, but I want to get rid of these fractions, so I'm going to fraction bust. Bust the fraction! I think of punching when I say fraction busting. Maybe you think of like explosions, or I don't know. Maybe you think of getting in trouble. Fraction busting. Oh, he got busted. Probably not what you think about. I can choose whichever constant because it doesn't have to be a specific polynomial. It's any polynomial with these as roots. So I'm just going to pick 2, and it will get rid of all my fractions. So I multiply that through, and I'll get 2x cubed minus 4x squared plus x squared. That's beautiful. Minus 2x, it really is. Minus 3x, again, beautiful. 3x plus 6 equals 0, because 2 times 0 is still 0. 0 is so powerful that way. You can just change anything to 0. It like absorbs everything with multiplication. I think it's pretty awesome. Okay, so I'm going to simplify. 2x cubed. Here's a 4x squared and an x squared, so minus 3x squared. And then here's an x and an x, so minus 5x plus 6 equals 0. Is this right? I think it is. Yes, it is. And that's my answer. It's a polynomial equation with integral coefficients. The way I got the integral coefficients was multiplying by 2 to get rid of the denominators. That's how I chose it. And yeah, I wrote down x minus the root times x minus the root times x minus the root equals 0. Multiplied it out. It's that simple. Some note that I want you to include is a little star. Note. If you're given for the roots, say you get 1 and they say it's a double root. So if you're given, if r is a double root, double rainbow, double root. I won't play that video again. Just kidding. I'll play it again. If r is a double root, meaning here, if it was 1 and it said double root, or it said 1, comma 1, saying a double root, write it twice. Write the factors twice. X minus 1 times x minus 1. So if it's a double root, write it twice. Like this. I.e. x minus r times x minus r times your other stuff. Yeah? Yes, very good, very good. Okay. Last example, number 10. Example 10. The instructions are just solve completely. You've done these steps before, so this shouldn't be too bad. It's just a little bit more involved. There's more things you have to do. So solve. And they'll give you an equation. 2x to the 4th minus 3x cubed minus 3x minus 2 equals 0. You're supposed to solve, and they'll give you roots. So the roots here are 2. I don't know why I underlined it. Just going to do a fraction. 2, and then negative 1/2. And they say these are roots. These are carrots and potatoes. So what I can do to reduce my equation for these types of problems, when it says solve and it's more than a quadratic equation, this is 4th degree polynomial equation. When I get these higher order polynomials and they tell me to solve, I can always reduce my equation down by synthetic division if they give me roots. And they do give me roots, so I'm going to do that. So I'll perform synthetic division with the 2 and make sure this is in standard form first, or descending order, and then do I need any placeholders? 4, 3, 2. I need a placeholder for 2, so actually I'm going to do that first. I need to start over talking about this. So the first thing that I'm going to do here is look to see if I need any placeholders. And we'll see here. So I have, it's in descending order. That's good. 4, 3, 2. I need a power of 2. So I need to add that in. So I have 2x to the 4th minus 3x cubed plus 0x squared. I need that. It's a placeholder, 0 placeholder. Squared to the 1 power to the 0 power. All right, awesome. That's all I needed. So I add that in. Now I can do synthetic division to reduce my my polynomial equation to a 3rd degree, and then I'll use the other root to a 2nd degree, and then maybe quadratic formula or factoring will work out. So here I'm going to do synthetic division with 2. And I'll have 2, negative 3, 0, negative 3, negative 2. Bring down the 2. 2 times 2 is 4. Add. That's 1. 2 times 1 is 2. 2 times 4. No, 2 times 2 is 4. Do you hear that? Car alarm? Some poor bloke having his car broken into. His coach. I don't know. That's 1. 2 times 1 is 2. Ah, very good. That's how I know I did it right, because they told me these were roots, so I know the remainder has to be 0. Then I can write a depressed equation. So sad. There'll be x, my x term, x squared, x cubed. So my other equation is 2x cubed. This is positive, so plus x squared plus 2x plus 1 equals 0. And I can do synthetic division again, except for this time, I don't have to use 2. I can use negative 1/2. Beautiful. So I have 2, 1, 2, 1. And I can go. 2, 1/2 times 2, this is easy. 1/2 times 2 is, or negative 1/2 times 2 is negative 1. Add that up, it's 0. So that's, this times 0 is 0. Add that together, it's 2. Negative 1/2 times 2, we did that before, is negative 1. Add them together, 0. Alright, great, beautiful. So now, I can write yet another depressed equation. This will be my x term, this will be my x squared term, so I have 2x squared plus 0x, I'm not even going to write it, plus 2 equals 0, and I can solve this by just subtracting 2 and dividing by 2 and then square rooting both sides. So subtract 2, and I'll take this up here. So I have 2x squared equals negative 2, divide both sides by 2, and I'll get x squared equals negative 1, square root both sides. Let me do that in green. Every time I do square root, it's plus and minus. So x equals, that's a plus sign, not an equal sign. Don't ever try to fool me with that. Equal sign, equals. Plus or minus, we took the square root of a negative, so that'll be I times square root of 1 is just 1, so I can just plus or minus I. Bada bing, bada boom. Yeah, so to solve means to find all the roots. So all of our roots, well, first we were given 2 of them, so I'm going to write those down. 2, negative 1/2, and then plus I and minus I. Those are all my roots. And it means I solved the equation. That's all, I think. Oh, right. Yeah, if you need help on this one, on this kind of stuff, then you can refer to example 8 to those steps, and they might help you out, because you're just really using those steps twice is what's happening. The end.